1, booster ignition, and liftoff of the maiden voyage of Endeavour on a satellite rescue mission.
For the past 2 decades, Space Shuttle Endeavour, the youngest vehicle in NASA's shuttle fleet, has symbolically carried the torch for Challenger, the orbiter it replaced. NASA is preparing for the final flight of Endeavour, a trip to the International Space Station during a time frame in which astronauts and cosmonauts are celebrating the 50th anniversaries of the first human spaceflight by Yuri Gagarin and the first American spaceflight by Alan Shepard, as well as the 30th anniversary of the first space shuttle flight, STS-1 Columbia. This historic 25th flight of Endeavour will include delivery of the Alpha Magnetic Spectrometer, a unique instrument that is hoped to unveil clues to the origin of our universe as it searches for antimatter, dark matter, and exotic cosmic particles from the space station. When Endeavour launches on NASA's 36th mission to the ISS, the STS-134 crew of 6 astronauts will begin a mission to stock the station with spare parts and a world-class stellar research instrument just months before the shuttle program comes to an end. Endeavour will deliver the Alpha Magnetic Spectrometer 2 and the Express Logistics Carrier 3 to the station. This will also be the first shuttle flight to conduct a re-rendezvous, but not dock to the space station, to test the performance of new navigation sensors designed for the Orion spacecraft. During 4 scheduled spacewalks, Endeavour's crew will conduct the last spacewalks by shuttle crew members to prepare the ISS for its next decade of service.
I've flown on Endeavour before, so I'm excited to fly on it again. And my brother's flown on Endeavour.
Navy Captain Mark Kelly is the commander of Endeavour's crew of 6 astronauts. He flew on Endeavour as the pilot of his first space flight, STS-108, in 2001. In January 2011, Kelly's wife, Congresswoman Gabrielle Giffords, was critically wounded during a community outreach event in Tucson, Arizona. Kelly took a brief leave from the agency, but returned to mission training a few weeks later. The pilot of Endeavour is retired Air Force Colonel Greg H. Johnson, making his 2nd spaceflight. He will be at the controls as Endeavour undocks from the station. He flew on Endeavour as the pilot of STS-123 in 2008. Air Force Colonel Mike Fink is Mission Specialist 1. A veteran of 2 long-duration missions on the International Space Station, he commanded the station complex on Expedition 18. During this mission, his first aboard the shuttle, he will conduct 3 spacewalks. Mission Specialist 2 is Italian Air Force Colonel Roberto Vittori, twice flown aboard a Russian Soyuz as an ISS visitor and part of the crew that delivered fresh Soyuz spacecraft to the outpost. As the last non-American astronaut scheduled to fly on the shuttle, Vittori will meet up with Paolo Nespoli on the ISS for 2 Italian astronauts on orbit at the same time. Dr. Drew Feustel, Mission Specialist 3, is making his first voyage to the ISS after performing 3 spacewalks during STS-125, the final Hubble Space Telescope servicing mission. On this flight, he will serve as lead spacewalker for 3 additional EVAs. Mission Specialist 4 is Dr. Greg Shamatoff. He served as an ISS flight engineer for 6 months during Expeditions 17 and 18, returning to Earth on Endeavour. He will perform 2 spacewalks.
We've got a whole list of mission objectives, probably 30 things on the list. But the big objectives is to get the Alpha Magnetic Spectrometer installed on the outside of the space station.
The Alpha Magnetic Spectrometer 1, a simplified cosmic ray detector, flew on STS-91 in June 1998. The AMS-2 is a first-of-its-kind instrument designed to study the fundamental nature of the universe and will allow us for the first time to search for antimatter and dark matter theorized to exist. Nobel physicist Dr. Samuel Ting leads the team of over 500 scientists from 16 countries.
I started studying physics. Soon after I achieved my degree as a test pilot, I went back and complete my degree. And ironically, my teacher was Professor Battiston, that is the deputy chief of the AMS experiment. So it may appear as a very strange coincidence that today I will be the one to take this unique piece of hardware, take it from the bay of the shuttle, and give it to install on the station.
On Flight Day 4, Vittori and Feustel, operating the shuttle arm, will grapple the AMS-2 and hand it off to the Gregs, Johnson and Shamatov, operating the station arm for robotic installation onto the station's S3 truss. The second of two components that Endeavour's crew will attach to the ISS is the ELC-3 pallet, the Express Logistics Carrier 3. ELC-3, similar to ELCs 1 and 2 delivered on STS-129, includes a full ATA, ammonia tank assembly, 2 SASs, S-band antenna support assemblies, and a spare arm for Dexter, the special-purpose dexterous manipulator. On Flight Day 3, Vittori and Fink will unberth the ELC-3 with the shuttle arm and hand it off to station arm operators Shamatov and Johnson for installation on the station's P3 truss. STS-134 will be the first shuttle flight to re-rendezvous with the ISS and to fly a rendezvous trajectory to mimic Orion's trajectory. The purpose of STORM, Sensor Test for Orion RELNAV Risk Mitigation, is to evaluate the performance of Orion relative navigation sensors for future spacecraft. While Kelly is flying Endeavour, Feustel will monitor STORM sensors from a laptop on the flight deck during rendezvous, undocking, and the re-rendezvous after the traditional ISS fly-around. Endeavour will pull away from station and execute several maneuvers before approaching on a different trajectory to allow the STORM vision navigation sensors to gather data. Although Endeavour will not actually redock with ISS, it will fly to a close approach of 1,044 feet below and 300 feet behind the station before executing a third separation burn and departing station for the final time.
Then when we come up back in front of the space station again, we're then going to do these series of burns where we're going to fall behind the space station, a couple 100,000 feet. And then we're going to come back in doing a profile that's actually quite similar to what Apollo used for a rendezvous.
During STS-134, Feustel, Fink, and Shamatov will take turns stepping outside the hatch for 4 scheduled spacewalks. EVA-1 on Flight Day 5 focuses on MISSIES, Materials International Space Station experiments. Feustel and Shamatov will return the MISSIE 7A and 7B pallets from the ELC-2 and transfer MISSIE 8 to the same location.
The idea is to expose these things to the harsh environment of space for a long period and see what happens.
For EVA-2 on Flight Day 7, Fink and Feustel will refill one of the station's port radiators with ammonia. They will also clean and lubricate the station's port Sarge, the solar array rotary joint. Prior to EVA-3, Feustel and Fink will test a new protocol combining the airlock campout pre-breathe, the exercise pre-breathe, and the spacesuit itself.
We were introduced to a pre-breathe option by Mike Gernhardt, an astronaut in the Corps, and it's called the In-Suit Light Exercise Pre-Breathe Protocol. We call it ISLE, I-S-L-E.
For EVA-3 on Flight Day 9, Feustel and Fink will install a power and data grapple fixture for the station arm on the Zarya module. They will also run 2 Y cables for redundant power supply to the Russian portion of the station. During EVA-4, Shamatov and Fink will transfer and install the OBSS, the shuttle arm's extension boom, to the station's S1 truss for potential future use aboard the ISS.
We have come very far in the last 50 years, from not being able to fly in space to landing on the moon and building this incredible facility in orbit and routinely flying, people up and down into low Earth orbit.
It is amazing how much we've accomplished in 50 years, and it took so many people to make all that possible. It's an unbelievable honor to kind of be the representative of that generation of dreamers for me.
We have a huge honor and responsibility to make this the best mission that we can, to honor all of the engineers all the way from the pre-STS-1 in the very beginning in the 1970s when we started to design the space shuttle. All the effort, the blood, the sweat, the tears that have gone into making the space shuttle program as wonderful as it has, to fly on the penultimate mission and to do it well and to do it with the honor of those that came before us.
Each member of the crew for Space Shuttle Endeavour's final flight has been to space before. In fact, STS-134 is the fourth trip to the International Space Station for U.S. Navy Captain Mark Kelly, tying the record for the most visits. Kelly was born in Orange, New Jersey, and grew up in West Orange. As a young boy watching the Apollo moon landings, he thought about becoming an astronaut, but as he got older, it seemed out of the question. After high school, Kelly won an appointment to the U.S. Merchant Marine Academy with a plan for a career at sea. Then he made a trip on a grain carrier.
Going from Seattle to a place called Savaga, Egypt. It's in the southern part of Egypt on the Red Sea. And getting across the Pacific, that ship went 12 knots. And it took us over a month to get across the Pacific Ocean and get us to Singapore. And I thought, boy, this is way too slow. So that's when I started thinking about flying airplanes in the Navy.
When he finished his bachelor's degrees in marine engineering and marine transportation at the Academy, Kelly took his commission and went to the Navy Flight School. He made 2 deployments during Operation Desert Storm and flew 39 combat missions, earned a Master of Science in Aeronautical Engineering at the Navy Postgraduate School, and then went to the Navy Test Pilot School, where the astronaut bug bit him again.
You know, being a test pilot's fun. You get to test new things and sometimes fly new airplanes. And the space shuttle, you know, after STS-134 only has 134 flights. It's still more or less in a test program, even though we've been flying it for nearly 30 years now. So it's like the ultimate test pilot job.
Kelly was an instructor at Test Pilot School when he was picked for the Astronaut Corps in 1996. Kelly was the pilot on shuttle mission STS-108 in 2001 and the second return-to-flight test mission in 2006. And he commanded the 2008 flight that delivered the Kibo laboratory module. Air Force Colonel Mike Fink has been to the station twice before. for a year on 2 long-duration missions, and he'll set a new record for time spent in space by an American at the end of this flight. Fink was born in Pittsburgh, Pennsylvania, and grew up in the suburb of Emsworth.
And I was the oldest of 9 kids. We didn't have a lot of money, but we're still able to spend time in planetariums and the museums and the science centers that are all over the city. Had a benefit and blessing to be able to go to a private high school. I had to work on the weekends to make it happen, but the school made it work too. And I had a great, excellent education in high school, studying science and math and all the things that really excited me.
Fink won an Air Force ROTC scholarship to MIT, where he earned bachelor's degrees in aeronautics and astronautics and Earth, atmospheric, and planetary sciences. That summer, he attended an exchange program with the Moscow Aviation Institute before heading to Stanford for a master's in aeronautics and astronautics. Then he started an abbreviated career as a fighter pilot.
And it turns out after 6 or 7 months, the Air Force and I both agreed that I wasn't going to be the God's gift to aviation that I thought I was going to be, and I wasn't destined to become a fighter pilot, so I washed out of pilot training.
Fink found his niche as an engineer and then a flight test engineer, attending the Air Force Test Pilot School and serving at posts in Southern California and later in Japan. But he never gave up his childhood dream.
When I was 3 years old, I remember watching people walk on the moon. And I knew right then and there that's something I wanted to do.
Fink was selected as an astronaut in 1996. He spent 6 months as flight engineer on the International Space Station's Expedition 9 in 2004 and performed 4 spacewalks. Then another 6 months as commander of Expedition 18 and performed 2 more EVAs. One of his crewmates from that flight is with him again on this one. Dr. Greg Shematoff was born in Montreal, Canada, and had a father he describes as a space fanatic. Shematoff remembers watching Star Trek as a little boy and being intrigued.
But then we went on a family vacation to Florida, and it was the time of Apollo 11, so we got to see the launch of Apollo 11 on a family vacation there. I was 6, and that was it. I told my dad at that point I wanted to do that and never changed my mind.
The family moved to the United States and settled in San Jose, California when Shematoff was 11. He graduated from high school there and went to Cal Poly in San Luis Obispo to study physics. The launch of the first space shuttle mission during his freshman year changed his focus.
And I just remember so vividly being in the dormitory, you know, people gathered to watch the first flight. And for me, you know, I'd wanted to do this all my life, but there wasn't, there yet wasn't any urgency or sense of direction, you know, of how to do it. And as soon as that happened, I said, I got to call NASA and ask them what I have to do.
When he got interested in robots, he changed his major and earned a Bachelor of Science in Electrical Engineering at Cal Poly, then a Master's in Aeronautical Engineering at Caltech. On a fellowship at Draper Laboratory in Cambridge, Massachusetts, Shematoff worked on spacecraft guidance controls for several NASA projects while earning his doctorate in aeronautics and astronautics at MIT. Then he taught aeronautical engineering at the University of Sydney before he came to work at the Johnson Space Center in 1995, developing software applications. He was picked for the astronaut corps in 1998 and spent 183 days in space as part of the space station's Expedition 17 and 18 crews. Italian Air Force Colonel Roberto Vittori of the European Space Agency has made 2 previous trips to the International Space Station, but he spent less than 3 weeks in space. Vittori was born in Viterbo and grew up in nearby Bomarzo in central Italy.
Very small, in the middle of a beautiful forest in countryside, and I grew up playing soccer outside my school. I was very good in defense, and that was and then I loved playing in the woods with my friends.
He left Bomarzo for college to study physics, but his boyhood interest in flying reasserted itself. Vittori earned a bachelor's degree in aeronautical science at the Italian Air Force Academy and completed his basic pilot training with the U.S. Air Force at Reese Air Force Base in Texas, and then flew operationally in the Italian Air Force. Next stop was the U.S. Navy Test Pilot School and a post-graduation trip with his classmates to visit NASA.
All my colleagues, American colleagues, were thinking about becoming an astronaut, and I was thinking, bad luck that I am not US. Obviously, in Italy, it's not that easy to have opportunities for astronauts.
2 years later, while Vittori was working as a test pilot in Italy, he put in an application when the Italian Space Agency was looking for astronauts. He was selected and became a European Space Agency astronaut and trained as a member of the 1998 class of astronauts at NASA's Johnson Space Center. Vittori flew to the International Space Station on a Soyuz taxi flight in 2002 and then on a 10-day science flight in 2005 during the Expedition 10 to 11 crew exchange. He later served as an Italian Air Force liaison officer and completed master's degrees in aeronautical sciences at the University of Naples and in physics at the University of Perugia. This flight is the second station trip for retired Air Force Colonel Greg Johnson. Johnson was a military brat, born in the United Kingdom and raised all over the United States. He was inspired to become an astronaut during a family visit to his grandparents in Traverse City, Michigan, when they all watched the Apollo 11 moon landing.
I was 7, my brother was 9, my sister was 11, and we were amazed, and I said, wow, I'd love to be an astronaut. So that was kind of the bit that was set way back when I was 7.
Johnson graduated from high school in Fairborn, Ohio, and went to the Air Force Academy to become a pilot and an engineer. After graduating with a Bachelor of Science in Aeronautical Engineering and earning a Master's in Flight Structures Engineering at Columbia, Johnson was assigned to Reese Air Force Base as a pilot and then a pilot instructor. He flew combat missions in Operations Desert Storm and Southern Watch before attending the Air Force Test Pilot School, which rejuvenated the engineer in him and made him think about his childhood dream of becoming an astronaut.
I'm flying really cool stuff, and they like to hire test pilots because each shuttle mission really is a test flight. And so went ahead and threw my name in the hat.
Johnson was selected by NASA in 1998, earned an MBA from the University of Texas at Austin in 2005, and piloted the 2008 shuttle flight that delivered the first components of Japan's Kibo laboratory complex. Dr. Drew Feustel's first spaceflight got him nowhere near the International Space Station, but he got up close to something that none of his crewmates has ever seen before. Feustel was born and raised in Lake Orion, Michigan, north of Detroit.
You have fond memories of summer and winter. You know, I think winters were quite enjoyable. We used to do a lot of snowmobiling and snow skiing, and in the summers we spent our time water skiing. And being a suburb of Detroit, Motor City, I became interested in automobiles at an early age.
Feustel raced motorcycles and go-karts as a boy, and he had cars in mind after high school when he went to Oakland Community College,
specializing in geology with a minor in industrial design. So you could say I was pursuing two careers, one as a scientist, one as an automotive designer,
while working as an automotive restoration mechanic. After he finished his associate's degree, he went to Purdue for a bachelor's in solid earth sciences and a master's in geophysics, and was the team kart driver for his fraternity. And then he earned a PhD in geological sciences at Queen's University in Kingston, Ontario. He worked as a geophysicist in Canada and then for ExxonMobil Exploration in Houston before he was picked as an astronaut in 2000. Feustel completed 3 spacewalks during the final servicing mission to the Hubble Space Telescope in 2009.
I think for humans it's always been about what's out there, are we alone, could we be the only ones in this infinite universe? And I think the only way we're going to find out is if we keep pushing the boundary and trying to get out there, and this is just the beginning.
And before we go, I want to highlight a love story that has been not getting much time lately in the spotlight. Obviously, I am not referring to Prince William and Kate Middleton. U.S. Congresswoman Gabrielle Giffords has flown to Florida, where her husband is getting ready to blast into space. It's been just 4 months since Giffords was shot in the head and nearly killed. But doctors say that she has made a remarkable recovery, and they cleared her to attend her husband's final launch aboard the Shuttle Endeavour. No doubt a very special moment for both of them. And that is Newsstream. But the news continues at CNN. World Business Today is next.
It's a bittersweet privilege to be taking Endeavour on its last flight, delivering the last major piece to the ISS.
I was there before they put the wings on it. It was just, so it was almost like it was my baby.
That space station assembly mission was perfect from start to finish, and a lot of that was Endeavour. It just, phenomenal vehicle.
The Eagle represents, the United States of America. It's something we're proud of. That's our bird. That's the Eagle.
After nearly 2 decades of achievements in space, Endeavour makes one last reach for the stars on its 25th and final mission. Endeavour is traveling to the International Space Station with 6 veteran space flyers: Commander Mark Kelly, pilot Greg H. Johnson, and mission specialist Mike Fink, Drew Feustel, Greg Shamatoff, and Roberto Vittori from Italy, representing the European Space Agency.
Well, I'm the commander of STS-134. We've got a whole list of mission objectives, probably 30 things on the list. But the big objectives is to get the alpha magnetic spectrometer installed on the outside of the space station.
The 15,000-pound AMS is a massive particle physics detector that will attach to the International Space Station. Its job, to search through cosmic rays, looking for proof of dark matter and antimatter.
In my mind, this is like the Hubble Space Telescope. I mean, it has the same type of potential for revolutionizing our understanding of the universe.
They're also delivering critical spare parts to help keep the station up and running for years to come, along with the shuttle's orbiter boom sensor system. Feustel, Fink, and Shamatoff will rotate through 4 spacewalks, the last performed by shuttle crew members for the remainder of the Space Shuttle program. And when Endeavour makes its final touchdown on the runway, it will end a storied flying career for the youngest of NASA's shuttle orbiters. Even Endeavour's beginnings were unique. It was built as a replacement for Space Shuttle Challenger, and named for the first ship commanded by explorer James Cook. At the time of the Challenger accident, astronaut Barbara Morgan was part of the Teacher in Space program, serving as backup to teacher Krista McAuliffe, who launched aboard Challenger on that fateful day in 1986.
I think Endeavour in particular, because she was named by school children all over the country, that really shows a carrying on and a moving forward, and how open-ended and never-ending that future can be.
Like all shuttle orbiters before it, Endeavour was built by Rockwell in Palmdale, California. That's where astronaut Bruce Melnick's bond with Endeavour began.
My first job as an astronaut, even before I was a qualified astronaut, was to represent the astronaut office out in Palmdale, where Endeavour was being built. So I got to see her being built from scratch to finish, got to see the wings put on, and it's amazing.
The nation's brand new space shuttle was delivered to Kennedy Space Center on May 7, 1991, exactly 1 year before its maiden flight.
It was great to see Endeavour come in. We knew why it was coming, because it was replacing Challenger. So it was going to be the new fleet leader and the new kid on the block.
Melnick was on Endeavour's first flight, STS-49. The 7-person crew faced an ambitious 8-day mission to repair the stranded Intelsat 6 satellite.
I'll never forget when Dan Brandenstein, who was the chief astronaut at the time, asked me if I wanted to be on the first flight of Endeavour. I mean, you could hear me hooting and hollering, because that was going to be the premier mission at the time.
Endeavour made history again during the last shuttle mission of 1993, when 7 astronauts upgraded the Hubble Space Telescope and improved its vision. It was an extremely complex flight, involving 5 back-to-back spacewalks. And in the end, all the hard work paid off. The telescope's new second-generation wide-field and planetary camera beamed back grand images taken with dazzling clarity. And Endeavour helped to carry the load in the construction of the International Space Station, including the very first shuttle flight to the fledgling outpost, STS-88. Endeavour delivered the American Unity module, and astronauts connected it to the Russian Zarya module already in place, and the station was born. Kennedy Space Center Director Bob Cabana commanded that cornerstone flight.
I have to admit, you know, because I got to command Endeavour on that first space station assembly mission, I'm a little partial to Endeavour.
Now, less than 3 years later, the nation was stunned by the terrorist attacks of September 11, 2001. On December 5th, all eyes turned to Kennedy Space Center, where Endeavour waited to make the first flight after the tragedy.
Mike, first we'd like to say thank you to the entire KSC team for getting Endeavour in great shape. And secondly, from the entire crew, we're all well aware that for over 200 years, and certainly over the last 2 months, freedom rings loud and clear across this country. But right here and right now, it's time to let freedom roar. Let's light them up.
One, we have booster ignition and liftoff of the Space Shuttle Endeavour, pushing our goals skyward using our station in space.
Endeavour lifted the nation's spirits with a spectacular launch at the twilight's last gleaming. After 2 more flights, Endeavour entered an extended downtime for planned maintenance and upgrades, including the new glass cockpit and a global positioning system for landing.
I think the missions you remember the most are the missions that were the toughest to get there, but we met our goals on the way. You know, we powered up in time after coming out of a major power down period and the major upgrades with the glass cockpit.
The newly upgraded orbiter returned to service in August 2007 on the STS-118 mission. Morgan flew as a mission specialist and recalls watching an orbital sunrise.
So I looked back up the horizon again, and there was a crescent moon. And it literally seemed, even though you can't, it's not this easy to do, but it literally seemed all we had to do was yank on the tiller, take a right turn, and sail straight to the moon. And that's when I really understood how natural and how right space exploration, human space exploration is. And Endeavour played a big part of that.
STS-134 will be Endeavour's 12th flight to the International Space Station. One of the most memorable deliveries was its most recent, the cupola with 7 windows, offering astronauts a room with a captivating view of their home world. After 30 years, the shuttle program is coming to a close.
When you look up and you see that vehicle take off the launch pad, I mean, it's just such a sense of pride, and you feel the shock waves hitting you in the chest, and it just vibrates you. It just brings a tear to your eye that, you know, we're a part of that program. And then to see Endeavour go up, the last ship that I flew, and I was on her maiden voyage, and she, you know, treated us so well. To see her go into space for the last time, knowing that she's going to be retired after this flight, is going to be a real sad day.
The vehicles we see, you know, every one of the vehicles, including Endeavour and Discovery and Atlantis, they're all part of us, and they all are, you know, they're alive, and they represent each and one of every one of us that had worked on it.
The close-knit shuttle processing team is adjusting to the shuttle's end while still maintaining laser-sharp focus on the job.
You know, personally, we do have to think about putting our emotions aside. We have our job number 1, which is to get this vehicle prepared safely for the mission at hand with STS-134 launch.
But the toughest moment will be that final wheel stop when Endeavour returns to Earth for good.
Houston, Endeavour, wheel stop.
Roger, wheel stop, Endeavour. Welcome home.
I didn't want to get out of the seat. I mean, this was my spaceship. You know, it really, that was hard getting out. In fact, of all the things I've done, it was hard. Getting out of that seat and giving Endeavour back to the team was, that was tough.
When Endeavour flies for the last time, it'll be show respect for everything that we've done for many, many years. We love the shuttle program, and we love this vehicle. Any vehicle that flies has to, you know, prove that it's flight worthy, and Endeavour did that. It's been a great vehicle.
Space Shuttle Endeavour, born out of the loss of the Space Shuttle Challenger in 1986, represented a commitment to continuing America's human spaceflight program. The nation's decision to build Endeavour set the stage for dramatic missions to come. The last of 5 orbiters to be built for spaceflight, Endeavour was named in a national competition by elementary and secondary school students after the 18th century sailing vessel commanded by Captain James Cook. Construction of Endeavour began with its contract award on July 31, 1987 to replace Challenger, which was lost 73 seconds after launch on January 28, 1986. Endeavour was outfitted with many safety improvements, including a drag chute to be deployed post-landing and nose-wheel steering to improve wear on the tires during rollout on the runway. Additionally, Endeavour's plumbing was designed for a state-of-the-art addition allowing for longer stays in space. Endeavour was delivered to NASA's Kennedy Space Center from its Palmdale, California construction site in May 1991. Endeavour's flight history has included some of the shuttle program's most memorable flights, starting with its very first mission, STS-49, in May 1992, just 1 year after Endeavour first arrived at the Kennedy Space Center for final processing. The primary goal of that mission was to rescue the Intelsat 6 satellite, stranded in low Earth orbit after launch atop an expendable rocket. It would be outfitted with a new motor, designed to boost the communications satellite to its operational orbit 22,000 miles above the Earth.
Ignition and liftoff of the maiden voyage of Endeavour on a satellite rescue mission.
For 2 spacewalks, astronauts Pierre Thuot and Rick Heeb tried to place a specially designed grapple bar on Intelsat to facilitate its capture with the shuttle's robot arm. When those attempts failed, the crew and mission control devised a dramatic plan calling for Thuot, Heeb, and a 3rd astronaut, Tom Akers, to reach up and grab the huge satellite by hand.
Let's do it. Got it. All got a good grip? Yes, sir. Houston, I think we got a satellite.
Yeah, we're watching down here. We got a lot of smiles down here, Dan.
It was, and still is, the only spacewalk ever performed by 3 people. The flight set a host of other records, including the most spacewalks on a shuttle mission to date, the longest spacewalk to date, and the longest spacewalk by a female to date. Endeavour continued that trend on its second mission, STS-47, in September 1992, a flight that conducted Japanese research in a laboratory in the cargo bay. The crew included the first African-American female to fly in space, astronaut Mae Jemison.
I think the important thing is for people to understand and to know that, yes, we do have and are willing to accept women and minorities as astronauts, and I hope that I'm just the first in a long line of African-American women who will be involved in the space program.
And we have liftoff. Liftoff of the Space Shuttle Endeavour on an ambitious mission to service the Hubble Space Telescope.
In December 1993, Endeavour was called upon to carry out the most ambitious shuttle mission to date on STS-61, the first Hubble Space Telescope servicing mission.
Houston, Endeavour has a firm handshake with Mr. Hubble's telescope.
With the world riveted on the mission's every move, 7 astronauts restored Hubble's vision during an unprecedented 5 spacewalks. The back-to-back EVAs were completed by 2 teams of spacewalkers who outfitted Hubble with a corrective optics instrument called COSTAR, installed a 2nd-generation wide-field planetary camera.
Hey, Diane.
Look how stable you left that.
Almost like a bird, Tom. Look at it.
If I can still see it.
And replaced Hubble's solar arrays. The mission lasted 11 days. Endeavour further pushed the boundaries of shuttle missions in March 1995. On STS-67, it flew an astronomy mission that became the longest shuttle flight to date, amassing over 16 days, 15 hours in orbit, conducting its studies with the suite of Astro 1 science instruments in the payload bay. The mission showcased the capabilities of the shuttle's fine steering jets, a system used to hold the instruments stable enough to focus on the stars and celestial phenomena as Endeavour circled the Earth at more than 17,000 miles per hour. 2 later missions for Endeavour continued the spacecraft's expansion of shuttle capabilities. On STS-69 in September 1995, Endeavour became the first shuttle to release and recapture 2 satellites during a single mission. And later, on mission STS-77 in May 1996, Endeavour completed a record 4 rendezvous in orbit with a research platform called Spartan.
And ready to fly.
2 years later, in December 1998, Endeavour was used to christen a new era in world space exploration. STS-88 would be the first International Space Station assembly mission. In Endeavour's payload bay was the Node 1 Unity module, the first U.S. component of the space station. Zarya, the Russian functional cargo block module, had been flown to orbit a few weeks earlier on a Russian Proton rocket from Kazakhstan. After Endeavour's rendezvous with Zarya, mission specialist Nancy Curry used the shuttle's robotic arm to capture Zarya and mated it to Unity, completing the very first ISS assembly operation.
Houston Endeavour, we have capture of Zarya.
We copy. Congratulations to the crew of the good ship Endeavour. That's terrific.
Several days later, Endeavour's crew became the first to board the new International Space Station. Mission Commander Bob Cabana and Russian cosmonaut Sergei Krikalev opened the hatches and entered the new international outpost together.
We are so pleased and excited and proud to be a part of the team that made this happen, and our special thanks to all the ISS folks, all their hard work. We remember when Unity was just an aluminum shell, and it is a truly fine piece of hardware.
When Endeavour made its next trip to the International Space Station on STS-97 in late November 2000, the space station was occupied by the Expedition 1 crew, and Endeavour became the first shuttle to visit a crew aboard the station. During STS-97, Endeavour was used to deliver and install the first set of U.S. solar arrays. The hatches stayed closed between Endeavour and the station for 5 days to allow the shuttle crew to conduct 3 spacewalks from Endeavour's airlock. After the EVAs were completed, the hatches were opened and the crew of Expedition 1 welcomed its visitors.
The crew requests permission to come aboard. Endeavour, permission granted. Endeavour arriving.
On April 19, 2001, Endeavour headed to orbit on STS-100. The mission delivered a new era in space robotics to the station, the 58-foot-long Canadarm2. Endeavour's crew performed the first operations in history using 2 robotic arms in space working together. Endeavour's robotic arm plus the new station arm to complete the mission. Dual robotics operations would become a mainstay of future station construction. Near the end of the mission, as the big arm handed its carrier to Endeavour's robotic arm, it marked the first robotic handshake in space. Between 2003 and 2006, Endeavour received a series of upgrades and safety modifications. Its first flight after those upgrades was STS-118 in August 2007. The mission was a fitting one for Endeavour, as the crew included mission specialist and educator astronaut Barbara Morgan, who served as the backup teacher in space to Christa McAuliffe, who was lost in the Challenger accident. Morgan made her historic flight aboard Endeavour to fulfill McAuliffe's legacy.
Some of my mentors that have meant more than anything to me are 7 very special people who I believe are mentors to you too. And that was the Challenger crew. They were my teachers, and I believe they are teaching us today still.
When Endeavour completes its final mission, it will have traveled more than 115 million miles during 25 trips to space. It will have carried 139 different people into orbit. Although Endeavour was the final space shuttle to be built, its career has been one of firsts, and its legacy will be one of opening humanity's greatest eye on the universe and expanding the space frontier for nations around the world.
For an out-of-this-world space laboratory.
Houston, Endeavour, roll program.
Roger, roll, Endeavour.
In preparation for Space Shuttle Endeavour's final launch, the STS-134 crew of 6 veteran astronauts flew T-38 training jets to NASA's Kennedy Space Center on the afternoon of March 29th. They came to the Florida launch site to conduct the standard week-long pre-launch training and countdown dress rehearsal, officially known as the Terminal Countdown Demonstration Test.
TCDT, or Terminal Countdown Test, is when the processing and the training kind of comes together after being parallel things for a very long period of time.
Commander Mark Kelly and pilot Greg Johnson got down to business the next morning with practice landings in shuttle training aircraft. The entire crew received instruction and practiced driving the M113 armored personnel carrier as part of its emergency exit training. At Launch Pad 39A, where Endeavour is undergoing final preparations, the astronauts inspected the payload for the mission, which is already tucked inside the shuttle's cargo bay. Severe weather closed in on the Space Coast for 24 hours, covering the area with heavy winds, rain, lightning, and hail. While the storms caused no significant damage at the launch pad, weather conditions caused some delays and reshuffling of training activities. This included moving the media Q&A normally held at the launch pad into Kennedy's television auditorium.
Every time you strap on a space shuttle, there is some intimidation among the crew members, knowing that there's just an awesome amount of power and something that's going to be a milestone in their life, whether it's the first time or the 4th time. And Mark and I were talking about it today, how excited we are to be flying Endeavour in a couple weeks.
With the sun shining again, the crew participated in the centerpiece of the week's activities, a launch dress rehearsal and practice countdown with the look and feel of a real launch day. The crew members also rehearsed launch pad emergency evacuation procedures. With the launch site exercises behind them, the astronauts returned to their home base, NASA's Johnson Space Center in Houston, where they will continue training before returning to Florida for their targeted April launch. At the launch pad, technicians will continue to prepare Space Shuttle Endeavour for its final flight, a 14-day mission to the International Space Station.
This is Shuttle Launch Control, T-minus 3 hours and holding. 1 hour, 11 minutes, 48 seconds remaining in this planned built-in hold. Right now we're going to look at some video of the activities that have been underway to prepare Space Shuttle Endeavour for its launch today. And then we will talk with Dana Hutcherson, who is the NASA Flow Director for Endeavour, known to us all as OV-105. So right now let's roll the video and look at some of the history of what we've done to get ready for STS-134.
Endeavour began its journey preparing for the STS-134 mission by landing at Kennedy Space Center on February 21st of last year. Later that evening, the towing operations were underway, bringing Endeavour back to Orbiter Processing Facility 2. Once rolled back into the processing facility, Endeavour was jacked and leveled and safing operations were initiated. Endeavour underwent maintenance operations, modifications, and inspections in preparation for its final mission. Technicians removed the orbiter boom sensor system, providing better accessibility for maintenance. The boom is an extension of the arm used for on-orbit inspections of the tiles and wing leading edge panels. With the sensor packages on the end, these cameras are able to provide data to the engineers on the ground, ensuring the vehicle is safe for re-entry. Although the boom removal is a standard operation, the work performed on the boom this time was a little unique. Additional modifications were made to the boom as the crew will leave the boom on the International Space Station this mission. One of the first operations performed in the Orbiter Processing Facility is to remove the 3 Space Shuttle main engines to begin the refurbishment process. In the shop, the engines undergo inspections, modifications, and repairs to prepare for its next use. Once refurbishment is complete, these engines were reinstalled on Endeavour. The Space Shuttle vehicle consists of 3 main components: the orbiter, twin solid rocket boosters, and the external tank. While preparing Orbiter Endeavour for launch, the solid rocket boosters were also being readied for launch. The 8 rocket motor segments were recovered from the last mission, refurbished, and reloaded with solid rocket propellant in Utah, then transported by train down to the Kennedy Space Center. Each segment was brought over to the vehicle assembly building where they were stacked onto the mobile launcher platform. Since the solid rocket boosters carry the weight of the entire shuttle vehicle stack, including the orbiter and the external tank, the criticality of inspections during stacking is essential to a safe flight. In particular, the seals between each segment were carefully inspected prior to mating the segment during the stacking operations. Each segment was then secured with 180 pins around the circumference. A couple of interesting facts to note. The left-hand forward motor segment was flown on STS-1. Additionally, due to a program change in the flight-assigned external tank for STS-134, the completed stack list the external tank was rolled around to a different high bay in the vehicle assembly building. The solid rocket booster stack roll-around operation has only occurred a few times during the shuttle program. Meanwhile, in the orbiter processing facility, the platforms were rotated back around the vehicle following main engine installations. Once the platforms were in place, engine leak checks, electrical testing, and closeouts were performed, followed by installation of the protective covers around each main engine nozzle. Each engine provides approximately 375,000 pounds of thrust during liftoff. The forward skirt and frustrum segments of the solid rocket boosters containing avionics, separation motors, and parachute assemblies were refurbished here at Kennedy Space Center and brought to the vehicle assembly building for stacking operations. External Tank 122 was assigned to the STS-134 mission in the fall of last year. As this was the last tank to depart the Michoud Assembly Facility in Louisiana, the team reflected on this milestone and celebrated the years of dedication and commitment to the Space Shuttle program. The final tank made the journey from Louisiana through the Gulf of Mexico and around Florida into Port Canaveral on a barge named Pegasus. ET-122 was originally built and planned for delivery to Kennedy Space Center in November of 2002, but the shipment was delayed due to a backlog of tanks at the Kennedy Space Center. After the Columbia accident in February of 2003, the tank required several modifications. While these modifications were underway in the vehicle assembly building at the Michoud facility in Louisiana, the building was damaged by the 2005 Hurricane Katrina. The tank's outer surface experienced only minor damages, which were subsequently repaired. These repairs can easily be seen on the tank as they are lighter in color. In 2008, the decision was made to perform detailed inspections and complete any remaining rework in order to manifest this tank back into the remaining flights. After spending over 10 years in Louisiana, ET-122 finally arrived at Kennedy Space Center on September 28, 2010. In addition to the repairs to the tank, you can also see the tank arrived at the launch site a darker tint of orange than most tanks due to the extended UV exposure to the foam, much like a suntan. As a tribute to the rich history of ET-122, the team designed this insignia reflecting the hurricane symbol and the space shuttle vehicle launching into space. The external tank was offloaded from the barge and transported to the vehicle assembly building, where it was then lifted into the checkout cell for pre-made operations and testing prior to mate with the solid rocket boosters. Once in the checkout cell, the team performed X-rays on this tank to look for any crack stringers similar to what had just been discovered with the STS-133 tank at the launch pad. Although the external tank looks like one large tank, it's actually made up of two internal tanks, with liquid oxygen stored in the top of the tank and liquid hydrogen at the bottom. The function of the external tank is to provide fuel to the 3 Space Shuttle main engines. On January 19th, the tank was transferred from the checkout cell to the integration cell in the vehicle assembly building with the help of overhead cranes. The tank was carefully lowered down in between the 2 solid rocket boosters that had previously been stacked on the mobile launcher platform. Once the external tank was mated to the solid rocket boosters, the checkout and closeouts were performed. Following tank mate to the solid rocket boosters, the precautionary stringer modification was also completed. This radius block modification to the upper portion of the stringers on the liquid oxygen side was similar to the modification performed on the last flown external tank. In the orbiter processing facility, Endeavour completed all required functional checkouts of major components, performed routine maintenance operations, and addressed all issues encountered on the last mission. The orbiter was secured to the orbiter transport system, which was built specifically for the orbiter. Endeavour was secured to the transporter using the same attach points that eventually connected her to the external tank. After spending over a year in the orbiter processing facility, Endeavour was ready to roll over to the vehicle assembly building. On the beautiful morning of February 28th, and only a few days after the launch of STS-134, Endeavour rolled out of the orbiter processing facility, beginning its journey toward the launch pad. Attached to the orbiter transporter, Endeavour proudly rolled over to the vehicle assembly building with a team of supporters cheering close by. As this was the last roll of Endeavour to the vehicle assembly building, the vehicle paused for a unique and rare opportunity, allowing employees to capture personal photos to document this historic milestone. Once rolled over to the vehicle assembly building, a lifting sling was attached to the orbiter where cranes were used to rotate and lift Endeavour. During the lifting operation, a great view of the tile was provided where final imagery of the lower surface of the vehicle was captured. During this flow, 141 tiles were replaced, including an experimental boundary layer transition modification with a protuberance tile. Lifting the nearly 200,000-pound orbiter requires the use of a 350-ton crane and a 250-ton crane. Once hanging in the vertical position, the smaller crane was disconnected while the larger crane lifted the orbiter up and over the transom into the integration cell. Teams of observers supported this operation as there are tight clearances rotating and lowering Endeavour in position for mate with the external tank. The orbiter to external tank mate process takes a few days, securing Endeavour in the 3 locations to the external tank. While in the vehicle assembly building, teams powered up the entire Space Shuttle vehicle for the first time and performed checkouts and testing. The Space Shuttle vehicle spent 11 days in the vehicle assembly building preparing for operations at the launch pad. In the meantime, Launch Pad A was being readied with only a few weeks between the STS-133 launch and Endeavour's arrival at the launch pad. After a short delay due to adverse weather in the launch complex area, the Space Shuttle vehicle began its journey to Launch Pad A on the evening of March 10th. Employees along with their friends and families were able to enjoy this incredible and unique view of rollout by watching nearby as the vehicle slowly moved toward the launch pad. The vehicle was transported by a crawler transporter the size of a baseball field, traveling over river rock 7 feet deep, the width of an 8-lane highway. Approximately 8 hours after leaving the vehicle assembly building and traveling less than 1 mile per hour, the vehicle was secured at the launch pad on the morning of March 11th. In the 7 weeks spent at Launch Pad A, operations including testing and checkout of the Space Shuttle vehicle, loading of the hypergolic fuel, payload installation and checkout, crew training, countdown simulations, and preparations for launch were completed. This will be the 25th and final flight for Endeavour, its silver anniversary, and the 134th Space Shuttle mission delivering the Alpha Magnetic Spectrometer and the Express Logistics Carrier 3 payloads to the International Space Station. The teams here at Kennedy Space Center are proud to be a part of Endeavour's historic achievements, which will always be remembered as a piece of the Space Shuttle program legacy. We will all look back on the accomplishments, knowing that we have played a small role in such a significant part of America's space program, and be proud to share this with generations to come.
Joining us now here in Firing Room 4 is Dana Hutcherson. She is the NASA Flow Director for Space Shuttle Endeavour, and she is, has been with this flow all the way from the beginning. And Dana, I think since this is the final launch for Endeavour, has the launch team done anything special on Endeavour during processing or to recognize Endeavour during the flow that, considering that it's the final mission?
Yeah, I think, we've done a couple of things to allow the employees to sit back and reflect on this. We've set up a couple of opportunities for photo opportunities to celebrate some of the milestones, such as rollover to the VAB. When Endeavour was rolled out, we stopped and paused and allowed employees to capture some photos there. And also, once we got to the pad, we had some opportunities for the employees to obtain some photos. But I think one of the best things that we've worked on is the team has worked on an Endeavour tribute poster, just to celebrate the life that Endeavour has had. And we've worked on that, and it's displayed in the firing room, and we have some words about it in the firing room for the tribute for Endeavour.
How about on the orbiter itself? Were there any special modifications made to Endeavour for this flow?
We do have one new modification. It's called the boundary layer transition modification. This mod is new to Endeavour. It's not new to the program. We've flown it a couple of times on Discovery, but it is a new modification for us. It's got a protuberance tile with a 1/2-inch protuberance on it, and we're going to just do some studies and some research for the future with that.
How about any other interesting facts about the 134 mission?
That's a good question. You know, I mentioned a little bit about this earlier, but external tank 122 has definitely had a rich history as well. It spent almost 10 years at the production facility in Michoud, and it also survived the Hurricane Katrina back in 2005. Had a couple of repairs after that, and also it was the last tank to be delivered here to Kennedy Space Center. One other thing on the solid rocket booster side is that we are flying the left-hand forward motor segment that actually flew on STS-1. So just a little bit of history that we're taking with us on this last mission.
Well, what are some of Endeavour's standout missions, more historic ones?
Well, I have to start off with its first, you know, STS-49, its maiden voyage in 1992. That was definitely a standout mission for Endeavour. Another one was the first Hubble Space Telescope servicing mission, and that was STS-61. One of the other ones that Endeavour has been known for is its first International Space Station assembly flight. That was STS-88. And lastly, if I could just say STS-134, I think this will definitely be a historic mission as well.
Well, what are your own thoughts about this being Endeavour's last mission?
You know, it's really hard to put into words, George. You know, I try not to think about it being the last. You know, I'll have some time to reflect on that a little bit later. But what I like to think about is, you know, Endeavour has had a distinguished history, you know, providing some of the greatest accomplishments to America's space shuttle program. And I try to look back and enjoy every moment of reflecting on Endeavour's history.
Well, we know that the decision has been made for Endeavour to go to California for display after the program's over. So do you think you'll go out there to see it once it's in place?
Absolutely. I do want to go and see it once it's displayed. You know, I don't think we've stopped learning from Endeavour, even though there's not another mission planned for it after STS-134. We can still learn, and, you know, our generations to come can still go out and look at Endeavour and share it with the whole world. We can learn a little bit more.
Well, Dana, thank you very much. And I know you'll be very busy during the rest of the countdown today, helping help us keep Endeavour on track for a launch this afternoon, and I know this is certainly a significant countdown for you. So thank you very much for talking to us and also narrating that flow tape, which really had some great footage of Endeavour being prepared for launch. Thanks very much.
Okay, thank you.
And we have 56 minutes, 36 seconds remaining in this planned built-in hold. We're at T-minus 3 hours and holding. This is Shuttle Launch Control. This is Shuttle Launch Control, T-minus 3 hours and holding with 54 minutes, 30 seconds remaining in this planned built-in hold. Joining us right now in Firing Room 4 is Joe DeLay. He is the Kennedy Space Center mission manager for the STS-134 mission. And in just a few moments, Joe is going to talk about some of the activities that have been going on here at Kennedy to prepare the payloads that are in Endeavour's payload bay for the launch today. Joe, first of all, when did the planning for the STS-134 payload operations begin?
George, that's a good question. AMS itself, that's one of the payloads on this mission, has been in work for almost 17 years. And then the ORUs, the orbital replacement units that are going to be flying up on this mission on Deck 3, have been in works for probably up to 7 years. And for about 1.5 years is when we started receiving the hardware to get here to Kennedy Space Center and work with the customers and finish integrating and go through various testing.
Well, involved in all of that, about how many people have there been directly involved with the payload activities that have been here at Kennedy working on it?
Oh, just from Kennedy Space Center as part of our mission processing team, I think at any one time we had up to 45 people working on different elements and different stages of the payloads.
Well, let's go ahead and roll the video now, and Joe, if you could tell us what we're seeing and walk us through the payload activities to get ready for today.
You bet. Okay, so what we're seeing here is the C5, and a couple years ago that brought Deck 3 to Kennedy Space Center. And later on the tape you'll see the deck, and this is what housed our orbital replacement units that we're bringing up. Some of the ORUs that we're bringing up are going to be used as spares in case we need them for space station. We're going to have an ammonia tank. We're going to have a high-pressure gas tank that's going to supply oxygen to station. We have a DoD experiment for low Earth orbit, which is a space test program, STPH-3, and you can see the deck in the container as they're getting ready to remove Deck 3 from the container. So basically we'll have up to 10 payloads or orbital replacement units on this deck that will be attached to station as part of this mission along with AMS. The Deck 3 is going to be attached to the P3 truss, and AMS will be attached to the S3 truss. On flight day 3, which is the docking day, is when they'll install the deck, and flight day 4 is when they'll install AMS. So here you can see one of the orbital replacement units I refer to as ORU, the SASA, which is an antenna that they use to talk with the shuttle or visiting vehicles to space station. This is a real unique mission. Just the weight of the ELC by itself is almost 14,000 pounds, and AMS is a little over 15,000 pounds. And here's some good shots of the team getting ready, the ammonia tank and the oxygen tanks, after we integrate them to be installed on the deck, finish our integration work, and then and do some testing. One thing on this mission that we are going to be bringing up, which we don't talk a whole lot about, are two more payloads that are going to be sidewalls called Missy and Storm. And Missy is a DoD payload, and it's going to characterize performance of new prospective spacecraft materials that can work in space and subject to space environments. And then Storm is a prototype system consisting of visual navigation, and a docking camera will advance the capability necessary for automated rendezvous and docking. So here's another good picture of the crew getting the other SASA ready to go into the deck. Okay, now this picture is of this Professor Ting. So this is the C5 when it brought AMS to us last August, and AMS is being removed from the C5 and brought over to the SSPF, where we'll work with Professor Ting and his crew, and we'll finish the integrating and the checkout of AMS. And as we go through these pictures of AMS, George, what I think is probably the most exciting objective of AMS is this is going to probe the unknown, to search for phenomena which exists in nature that we have not yet imagined nor had the tools to discover. So it's a fantastic experiment, and we look forward to working with Professor Ting and his crew for the next 10 years or so as we gather information from space and determine the particles that are going to be brought through AMS. And each particle is charged, and the magnet's going to help with that. And the particles will be deflected, and they can take a look at the mass and tell all sorts of things about the particle. And hopefully that's designed to it's kind of like a particle detector to search for antimatter and dark matter on orbit. So here's AMS as it's being lifted from its GSE stand, the ground support stand, and it looks like we're going to get ready to do a weight and CG on it and bring it into the canister and get ready to go to the pad, which we did that back on the 22nd of March. Yeah, a little more. You know, the orbital replacement units, we had folks from all over the world working with us. We had the DoD. Here we have AMS, which is being worked by 16 countries and the best physicists. They all come together to design and build a particle, as I mentioned, to search for antimatter and dark matter. It's a DOE NASA sponsored payload with various high energy physicists and their institutes from all over the world. Very unique.
Scott, the weighing's complete. You can start measuring and
So it looks like we're getting ready to bring it. It looks like we already have the in there, and the AMS is being loaded. And then off we go to the pad, and I think we'll have some pictures coming up of the canister with the payloads going to the pad. And while we have a second here, George, I'd like to talk about, besides the payloads we talked about, here's a picture of the deck being lifted into the canister. You can see the ORUs, the goldish color was the STP-3, the DoD payload. And we talked about AMS, and we talked about the deck, and we talked about Storm, and we talked about Missy, but we also have mid-decks going up on this flight. We have a couple powered mid-decks, Glacier and CGBA, and then we have various non-powered decks, and these are non-powered mid-decks. And these range from biology experiments, medical experiments, experiments to help detect cures for different diseases that we'll have here on Earth. The list is endless on the mid-decks that we have going up on this mission. And it's just a fascinating flight when you take a look at the different payloads and all the different mid-decks we have going on this flight. So here we have the canister, which is being brought into the canister rotation facility. And we have to rotate it from horizontal to vertical in order to get ready to go to the pad, and then attach all the payloads into the orbiter, and that'll be coming up in a second. That's a very delicate operation. It's all manual. When you go from the horizontal position to the vertical position, it looks like the canister is rolling to the pad, which takes about 2.5 hours. And of course, once we get to the pad, they go ahead and install into the orbiter, and we did that on the 26th of March, which is about 4 days after we got to the pad. And then once we're in the orbiter, we have to make sure that all the payloads again work, and they can talk to the orbiter. And we call that an IVT, interface verification test. And this is a beautiful picture of the canister making its way up the launch pad and getting ready to be for the canister to be lifted, and the payloads brought into the orbiter. And then one of the tests that we did in this mission, which was kind of unique, is what we call an end-to-end test. And we just wanted to make sure that AMS itself would talk to our JC friends, because once on orbit, the JC will be working with AMS, and then eventually that will be the command control center will be brought over to CERN, where they'll take over. And then we did our final bay closeouts on the 26th of April, and we just finished yesterday our mid-deck late stow with the mid-decks I mentioned, and that went flawless. And of course, here we are for launch.
Let's take a look at some of the other stories making news around the world. This may be giving you a hint behind me. It's a historic day, I should say, the launch of the Space Shuttle Endeavour. It is set to lift off for a final time in a few hours. What will the forecast be? The all-important weather forecast when it comes to Space Shuttle launches. Who better than Mari Ramos to tell us about it? Because Mari, you are such a huge space fan, and I have to ask you on this day, I mean, it's basically over.
It is basically over, at least for Endeavour, right? And of course, the final shuttle missions now. 500,000 gallons of liquid hydrogen and liquid oxygen are now on board that space shuttle right now, Endeavour, and it continues its final preparations right now, Hala, for liftoff. NASA is right now saying there's about a 70% chance that the weather will cooperate, and that's actually pretty good. Just in the last hour or so, there was a pretty strong thunderstorm that was kind of zooming through here. You can see all of that moisture coming along. This is actually, Hala, the tail end of that same front that caused all of that nasty weather across the southeastern U.S. over the last few days. So it's still causing a few problems across some of these areas right in here. So that moves on. The concern weather-wise will be the possibility of some strong crosswinds that will be coming along this area here. So the final Endeavour launch expected to happen just in the next few hours at around 3:47 Eastern Time, 1947 GMT. Sky conditions mostly to partly cloudy. The wind still expected to be maybe 25 to 30 kilometers per hour, and that's the concern because when the shuttle's taking off, those winds that are moving across this way could, you know, they have a threshold for that. Right now, it's within that threshold. If they're higher than that, it could postpone the launch. So right now, they're saying it's still a go, though. The temperature, not bad at all, between 24 and 26 degrees Celsius at the time of the launch, Hala. So far, so good, and yes, bittersweet for all of us that love spaceflight.
But the good news, though, is that the commander of the mission's wife, Gabrielle Giffords, who was shot in the head, of course, in Arizona just a few months ago, will be attending. We won't see her, but at least she's well enough to make the trip and see her husband off. So there is some good news there.
Her husband's the shuttle commander. So
he's the shuttle commander, Mark Kelly. All right, thanks very much, Mari Ramos, and we'll catch up with Mari again a little bit later.
This is Shuttle Launch Control. Our NASA Launch Director, Mike Leinbach, has made the decision based on input from the engineering community that we're not able to resolve this situation with the APU heaters in time to make a launch attempt today. There's not a way to do the kind of troubleshooting that we need to do and still be able to stay in a countdown configuration. So we will be scrubbing for today. Right now, it will be at least a 48-hour scrub turnaround while we try to get a better handle on what will be necessary to understand better what the problem is. And as we have been able to piece it together, there will be some entry into the aft necessary to do that kind of troubleshooting. But in any event, because of this problem with two failed APU heaters in APU number 1 and not able to find a satisfactory workaround or to understand what the problem is that's caused these two heaters to fail, the decision was made and concurred by Houston Flight that we will scrub for today. We will put together a troubleshooting plan. It will be at least a 48-hour scrub. That does not mean that that is a final determination of how long before our next launch attempt will be, but we know that it will be no earlier than Sunday.
Some developments coming to us, as we noted, while history is made there in London, they were hoping to make some history down at the Kennedy Space Center in Florida, not to be this day. As the U.S. winds down the Space Shuttle program, it was hoped that Shuttle Endeavour would wing its way into orbit for its final voyage into space. Let's get more from John Zarella about what happened and what's next.
Yeah, Jim, not a good day here at the Kennedy Space Center. Everybody, of course, very excited. The president and his family are going to be here. Gabrielle Giffords, the congresswoman, wife of Commander Mark Kelly, she was going to be here less than 4 months after being shot and nearly killed. She is here, and we know that. Now the question is, what happens? When will Endeavour lift off? What happened was that they discovered a problem with heating units in one of the 3 auxiliary power units. These heating elements were not working, and they are important because in order for the shuttle to have maneuverability, the elevons, the rudder, the steering controls on the shuttle, that all comes from the auxiliary power units. The fuel, hydrazine, is what controls those steering elements. That's what's used. And they need the heaters to keep that hydrazine, because it is super cold, from freezing up. So without these heaters operating, they cannot fly. So the astronauts, the crew was literally on its way out to the launch pad. In fact, they had just stopped right here near us by the vehicle assembly building and got the word that the launch had been scrubbed, and they turned around and headed back to what's known as the operations and checkout building, where they'll get out of their spacesuits and relax until we find out exactly how long this delay is going to be. No less than 48 hours, and we're hearing that it could be substantially longer than that, maybe perhaps 3 to 5 days delayed, because they've got to drain out the giant external tank with the 500,000 gallons of liquid hydrogen and liquid oxygen before the engineering teams can get in there to try and figure out what exactly the problem is. Jim?
You know, the big question a lot of people might have is this problem and delay really related to the age of the space shuttle fleet?
You know, I don't think so. I mean, certainly you could argue that what it's related to is the complexity of these vehicles, which is one of the reasons why the shuttle program is coming to an end. You know, it's $500 million every time you launch one of these shuttles. And the fact is that it's one of the perhaps the most complicated vehicle ever built by humans. So these things go wrong, and unfortunately they go wrong far more often than anyone would like it to happen. Is it aged? No, because these parts are upgraded and replaced. So it's not that, but it is the complexity of the vehicles. And there are so many moving parts and so many things that can go wrong, and this is just another one of them. Jim?
Probably a lot of disappointed people, because I know people that come from all over the U.S. and from many parts of the world. A lot of people were there, and they wanted to see all of this. Now, John, we'll just have to wait and find out when Endeavour.
Yeah, half a million people were expected here to watch. So, yeah, we're just going to have to wait and see.
John Zarella, there at Kennedy Space Center. As always, John, great to talk with you. Great to have somebody with your expertise about these complex issues like the space shuttle to explain it all to us. Mari Ramos, another person with a lot of expertise, joining us now from the International Weather Center with a look at not only the forecast over that space center, but also the perfect weather that we've been seeing on the wedding day. You were pretty enthused, I know.
So beautiful, I know. You know what, let's go ahead and start with the space shuttle. I know, for those of you that are watching out there, I know the heartbreak that comes whenever there is a scrub of a space shuttle launch. I was out there once, and it got scrubbed because of some conditions there, some faulty conditions. It was a discovery mission, and it was heartbreaking. And I know for all of those people out there waiting, you're waiting, and then they tell you it's scrubbed. Well, safety comes first, as John Zarella was telling us, and sometimes we think it's going to be things like this. This is the shuttle just about 24 hours ago, the night before, where there were some storms rolling through here. There were a few storms rolling through here earlier today, but those have come and gone. The weather was actually pretty good for this launch, but as he said, those auxiliary power units, the concern. This front that you see moving through here, through Florida, Jim, is the same one that caused all of that nasty weather here across the southeastern U.S. So this is the tail end of that weather system moving right on through. As we head through the next few days, there are no big weather systems expected. An area of high pressure kind of settles in across this region here, and even for the areas affected by the tornadoes, they should have some pretty decent weather for the recovery process, even as we head into the weekend. The 48-hour mark here for a possible relaunch at the Kennedy Space Center looks pretty good weather-wise, so we're not going to be too concerned with that for now.
This is Shuttle Launch Control. Joining us now in Firing Room 4 at our Public Affairs Console is our Space Shuttle Launch Director, Mike Leinbach. And Mike, I think we're looking at you to kind of explain how this problem evolved, what it is that you are seeing, and maybe give us some idea what the go-forward plan is and how much time are we going to need to turn around.
Okay, I'll be glad to do that. And can you hear me okay? I wasn't hearing you all that well, but well, let's see. The issue is with one of our auxiliary power units, which provides the power to the hydraulic system for the orbiter. And the exact problem was a thermostat on one of the fuel lines for that auxiliary power unit. and we need to keep those lines warm to prevent them from freezing on orbit. So we have 2 thermostats, 2 heaters for each fuel line for each APU. And on auxiliary power unit number 1, one of those 2 heater units failed, and the troubleshooting we did on it proved that it was a hard failure. We were not able to get it to come to life no matter what we did. We tried to let the line cool down just by normal means and to see if the thermostat on that heater would kick in. That did not happen. We tried to command the heater from the cockpit of the orbiter. That did not happen either. So we know we have a hard failure in that heater string for that one auxiliary power unit. There was another heater upstream of that is also exhibiting some funny behavior. So what we believe we have now is a problem in one of our LCAs, a load control assembly. It's essentially a switch box that says we probably have a failure, a short, actually in that box or in one of the electrical lines to that box or from that box. We're not quite sure yet. We won't know until we get into after the orbiter and do some detailed troubleshooting. But the issue is that we didn't want to commit to flight with only one of 2 heaters on those auxiliary power unit fuel line, because of the chance that if you lost that one good one on orbit, then you run the very high risk of freezing the fuel in that line, and therefore the auxiliary power unit would not function, and therefore you wouldn't have full hydraulic power, which is a case you never want to get into for re-entry without hydraulic power coming from one of the 3 auxiliary power units. So the course of action today is to scrub. We're in the process of draining the external tank right now. That'll take another hour or so. We'll set up to gain entry into the aft compartment of the orbiter overnight tonight, and probably tomorrow afternoon we'll get into the aft, start putting in our platform set to get to this load control assembly, which is down inside the aft quite a ways, and so it's going to take us a bit of time to get in and do that. And then once we're in the avionics bay where that LCA exists, we'll be able to do our troubleshooting and see if we need to change out that box or whether we find a short in the line, that type of thing. So right now, it obviously a scrub turnaround scenario of a minimum of 72 hours right now. We've declared a minimum of 72. And I'm going to have a scrub turnaround meeting with my launch team at 2:30 today where we will refine that plan based on engineering's input to see what level of troubleshooting they want to do to see if it extends that 72 hours even longer than that. But today the orbiter is not ready to fly, and as we always say in this business, we will not fly before we're ready, and so that's the case we're in today.
So right now we're no less than 72 hours, but till you get through the troubleshooting in the aft, you really can't tell how much more time we would need.
That's exactly right. We're absolute minimum 3-day scrub turnaround now.
All right, Mike, well, thank you very much. And that will conclude our launch commentary at this time. This is Shuttle Launch Control.
I'll go in and see you.
Don't break anything. That's that is called. We're going to shoot you.
All right. Pete, get up for us, man.
So we're on this. How are you shooting today? Good to see you. Hopefully they can. So nice to see you. That's my mustache too. I like that. Fantastic.
The astronauts are going to see. Something very interesting about it. You saw how lightweight it is. Right. This is just the top material. But how many coats? This is what happens. Here's the driver. Here's the button. See all that water?
Soaks it up.
So give it a while. Keep squeezing. Here, let's go upside down the water. That's it after.
How about that?
But the tile,
those would be replacement tiles.
yeah, but all these
It's like your bedroom.
well, 30 feet high.
Thanks for keeping our astronauts cool. Appreciate it.
Thank you.
Thank you very much.
I'm glad you could get here today. It's an amazing vehicle.
There's the landing gear. Look how tough this is. How much of that is orbiting? How much of that is you guys going to the space station?
Yeah, we'll dock it.
Who's going to be walking?
Oh, no. Oh, I'm sorry.
His first time to go out. So we're,
oh, is that right?
Yeah, we're excited.
It's going to be your first walk, huh?
Yeah.
That's going to be pretty cool.
Yeah, 3 of us are doing space. We have 4. I don't put this.
We have 4 spacewalks.
3 people that do it. So you're on the East Coast. Yeah.
It's 2 hour flight. We can make this.
I think they're going to take you over to see the
I took a picture of my dad's house and his house.
Who was coughing over there, by the way? Stay away from my astronauts. Don't think I didn't hear that.
Thank you so much.
We'll see that. This turned out.
All right, Paul.
Thank you.
I hope you can make it. Come back. Try to come down.
Whose stuff is this?
Oh, mine.
All right, we got.
Despite Friday's scrubbed shuttle launch attempt, President Obama and his wife Michelle, their 2 daughters, and his mother-in-law arrived Friday afternoon at the Cape Canaveral Air Force Station aboard Air Force One for a visit to NASA's Kennedy Space Center. Instead of watching Endeavour's launch, the first family boarded the Marine One helicopter and headed to the orbiter processing facility at KSC for a tour. Inside the OPF, the Obamas were given a close-up look at Orbiter Atlantis, which is undergoing pre-flight preparation for its and the shuttle program's final mission, STS-135.
Thanks for keeping our astronauts cool. Appreciate it.
That flight has been targeted for late June.
Here's the landing gear. Look how tough that is.
The president and family also visited Kennedy's Launch Control Center, where he talked with the 6 Endeavour crew members led by Commander Mark Kelly.
Who was coughing over there, by the way? Stay away from my astronauts. Don't think I didn't hear that.
The Obamas then returned to what's known at Cape Canaveral as the Skid Strip, where they boarded Air Force One bound for Miami, where the president was scheduled to deliver a commencement address.